Good afternoon. I'm Ben Holderman, the Student Project Manager of the Panama Bridge Project. With me today are Katie Barrett and Ben Reiner. Our project is one of three bridge projects in the Collaboratory. Our team is specifically focused on bridges in Panama. We have 8 students volunteering working on our team. 1 senior, 2 juniors, 2 sophomores, and 3 first-year students. Our project is partnered with 3 different organizations: the Collaboratory at Messiah College, Rio Missions, and Bridges to Prosperity. The Collaboratory at Messiah College gives us the opportunity to do these kind of projects. And our mission is to design and construct bridges in partnership with local communities in Panama to increase their access to essential resources and economic opportunities.
So taking some steps back and giving a brief history of the Panama Bridge Project, we began about 3 summers ago when Russell Wolfslogel, who was our student project manager at that time, felt called to help a Panamanian pastor connect 2 halves of his community, Arejan. And really starting with only this dream, the Collaboratory here and the engineering department here supported Russ as he assembled a team of students, he learned the basics of bridge engineering, and then ultimately designed a 40-foot wood truss bridge. 2 summers ago, we built that bridge, and we started asking the question, what's next? Well, as it turns out, our client Rio Missions had its eyes on another location, the small towns of Bajo Grande and Lejiji, about 5 hours away from Arejan and Panama City. We accepted the offer to partner again, and this time designed a 230-foot cable suspended bridge at this location. During this time, we also brought on Bridges to Prosperity as a technical partner. And then last summer, a team of about 15 students traveled to Panama and guided the communities through the construction process. We aren't done with Bajo Grande, and I'll address that momentarily, but first I want to answer 2 questions regarding our project. The first being why bridges? And this really comes down to access. We often associate education, healthcare, economic centers with poverty. When accessibility to these resources is threatened, transportation infrastructure becomes the essential need. And this is the reality for many people in the rural tropics. So a river such as the one above may be crossable in the dry season. The wet season can change rapidly. And we experienced this last year and can stay high for hours to days. And while this is definitely problematic for kids getting to school or farmers getting to the fields, imagine if there's a medical emergency. The person's probably out of luck. So our desire to give people access to these resources really drives and motivates the project. The second question then is, out of all the tropical rural communities in Panama and even the world, why Bajo Grande? And the first reason is that our client Rio Missions is heavily involved in supporting the local churches in Bajo Grande. We really want to partner with the community where there's good in-country support to ensure the project's appropriate, well received, and then followed up on. The second reason is that the regional government supports us. You can see a picture of the mayor above. He has confirmed the need in the current location and is willing to support us with resources. And then finally, there's a real need in the communities due to the geographic location. Now, I know it's difficult to decipher topography from a satellite image, but the towns of Bajo Grande and Lejiji are actually in a river valley where the river snakes back and forth, cutting off road access at multiple points. Bajo Grande is actually on sort of an island, you can see, with mountains on both sides and then the river. And because of this, we're able to return there this year and build another site. Last year's bridge focused on connecting the west side, and this year's bridge will focus on the east side. In a sense, there's 2 needs. There's the need to give kids in Lejiji access to their school in Bajo Grande, and there's the need to give residents of Bajo Grande and Lejiji access to the medical facilities, markets, and so forth in Mariato, which is a larger town further down the valley. So taking a closer look at our current site, you can see the existing bridge pictured above, and this really isn't much more than scrap wood and wire. And while it's not a bad bridge, given the materials that were used to make it, it's not a safe long-term option. And furthermore, it's built in such a way that elderly people, disabled people, and young children really are unable to use it. Rio wants us to partner with them again in designing for this site. We actually, in our initial site planning, we chose to change the location of the bridge, and you can see that change on the map. Where the existing bridge is, it's at the base of a hill, and the terrain has posed some design challenges for the subterranean construction, and then also achieving an acceptable height differential between the sides. So the new location provides enough space for construction and also a desirable bank elevation. I'll pass it off to Katie and she will talk more about the bridge design.
So here's the timeline of our project as a whole. And Rio Missions has been developing this relationship with the community for a long time, and we came in 2 years ago to construct our first bridge, and then built the first bridge for Bajo Grande last year. And this semester and this year we've been working on the bridge design for our current bridge, which we'll construct in this summer for a 7-week construction project. This is a general free body diagram of a bridge of our magnitude. The basics of design of a bridge of our magnitude is to have enough friction force to resist the cable tension provided by the distributed load over the span. The first step of any bridge design is to determine the site viability and the dimensions of our site. We'll have an 80-meter span, which is about 260 feet. The length of the span and material accessibility to the site necessitated that we use a cable suspended bridge instead of the wooden truss bridges of the past. Also, with our current site, we needed to make sure that we had a setback more than 35 degrees from the bank of the river, and also a height difference which is less than the length divided by 25, which is 3.2 meters. And our height difference is 2.9, so we easily cleared that. We also needed to make sure that we had enough freeboard, which is the height of the bridge above the high water line of the river, over 3 meters, which is the minimum height differential for a gorge type location. The demand on the bridge abutment is mostly from the cable tension. Our decking is guayacán, which is the hardest wood in the world. It's also nice because we can locally source it from the mountains of Panama. We have a crossbeam every meter supporting the staggered floor beams, and we found our service load to be a combination of dead load and live load of 85.2 pounds per square foot over the span of the entire 80-meter bridge. This is enough for a person to safely walk their horse across the bridge. We use the sag value of 5%, which is an amount that's been proven efficient in the past. This value is important because if our sag is too tight, then the cable tension will increase drastically. And if the sag is too loose, then it will move too much when you walk across it. After finding the maximum axial tension of the bridge, which is 66.5 tons, we use the breaking strength of a bunch of different cables with different diameters to determine how many and what kind of cables we would use. We determined to use 5 1.25 inch cables, which have a breaking strength of 58 tons to span across the bridge length. This gave us a comfortable factor of safety of 4.46. The cable size is also nice because we have a couple remaining 1.25 inch cables on site from the bridge construction last year. In addition to the large magnitude of the horizontal force component from the cable tension, we also have some pressure from the earth pressing on the back of the anchor. This is called active earth pressure. With our current soil density, the total force is 8 tons, which is relatively small compared to the 67-ton cable force of the span, but it still needs to be accounted for. And again, the only way to resist a horizontal force in a bridge is to have enough friction force to resist that. And how do you get enough friction force? Provide a lot of normal force. This is all from the weights of the abutment, ramp, and anchor. First, we have a masonry wall foundation filled with rocks and soil over a concrete slab and capped by a 10-centimeter concrete slab. Sitting on top of this are the block wall tiers. The slab has a hole in the middle so that the fill of the tiers and of the tower and of the foundation can act as one entity, providing a greater structural advantage for the abutment. Last year's bridge only had 1 tier, but this year's bridge will have 2, which provides some significant construction time constraints. The towers also have masonry walls, but are filled with reinforced concrete, capped with a concrete cap encasing a tire rim to saddle the cables of the handrails. There's a reinforced concrete anchor with tubing through it for the cable to run through. The ramp walls are structural, made of river rock, while the entire ramp is backfilled with the previously excavated soil. The entire weight of each abutment is 329 tons, comprising mostly of the ramp walls and fill. In addition to the massive structural pieces, a small amount of vertical force is provided by the cable tension. With this design, we did have enough frictional resistance to exceed the horizontal component of the cable tension and the active earth pressure by greater than 80%.
The Collaboratory gives us, as students, a special opportunity not only to design, but also to make our designs a reality. In addition to the design work we've completed, we have also done a lot of work planning for the construction of this new bridge. This past January, we sent a team of 2 students and an advisor to Panama. The team had 3 goals. 1, to prepare the bridge site for the summer construction. 2, to begin material collection of river rock, sand, gravel, cement, and any other type of building material that we may need. And 3, to get the community excited and ready for the construction of this bridge. This goal is important for the success of the project because without the help of the community, we would not be able to complete this bridge. Overall, these goals were to help Rio Missions with any responsibilities needed to be completed in order to prepare for the summer travel teams. In addition, we've been working on preparing as a team here at school. We've designed a construction schedule using a Gantt chart, which is commonly used by many construction companies here in the States. This schedule outlines critical phases of the project that need to be completed in order to stay on task to finish the bridge. We have set 7 weeks for the summer trip. Therefore, this restricts the amount of time we have to build, making it more important that we do our best to stay on track according to our schedule in order to finish before we leave country. We've also done material estimating to give Rio Missions a good idea of how much materials they need to fundraise and acquire for the bridge. Calculating the material estimates as soon as possible ensures that we will have the materials arrive when we need them. Getting materials delivered on time is crucial to being able to keep to our construction schedule. Other construction planning includes assigning construction roles to each of the students. As students, we are in charge of the design. This role is also applicable to construction. Roles during construction include a site team leader, a construction manager, materials and equipment managers, and safety managers. Safety is key to the construction of a project, and safe work environment comes from safely minded workers. So to develop an environment of safety, every person traveling has become OSHA certified. The construction of this bridge will take place this summer, from mid-May to the beginning of July. It will consist of 2 teams, each traveling for 3.5 weeks in length. We're all so excited to travel and work with the people of Panama to show them our love by building this bridge with them in community. We would like to acknowledge everyone who played a role in the success of this project. Our faculty, Dr. Brian Swartz, and our professional advisors, Brian Hoover and Tim Zimmerman, all put much of their time towards this team. The advisors who have traveled and who will be traveling with the site teams make it possible for us to go and actually build these designs. We would also like to highlight our project partners, Rio Missions and Bridges to Prosperity, as well as our many corporate sponsors. The work we do is only possible due to the support of all of these people. Each play a special role in the success of our project. Thank you. Are there any questions? Yes?
And when you showed your new location, it looked like there was a road went furthest down, but your location for your bridge seems to be far from the road. Why was that location selected and not closer to the road?
Yeah. I'm going to jump back to that slide.
We selected that site mostly because of the surrounding environment. There's a lot of forestry along the river, and this had a good place for us to span the bridge. And also, I think the other bridge, the smaller existing bridge, is also significantly off the road, and you have to kind of trek through the mountains in order to get there. So this one will be more easily accessible from the road in general.
Yeah.
When building these bridges, do you take into consideration of possible wood decay, weather conditions, and insects or anything that can eat the wood, and what do you do to prevent these?
The question is, what are we doing to help sustain the life of the bridge? And like we said before, Rio Missions is heavily involved with these towns and communities. So Rio Missions will be there, and like if they see that the bridge needs work on, they will have teams come down and help replace decking. We do stuff like coating the cable in tar while it's underground so that it doesn't rot away and decay. So things like that will help keep the bridge in prime condition as long as possible.
And that's also partially why we use guaiacom, the wood that's the hardest wood in the world, because it's hard to find locally, but we can locally source it, and it does have a longer durability over the lifespan of the bridge. Yeah?
How do you establish the high water level of the river? Where do you get that information?
The question was, how do we establish the high water level of the river? In communities like this, we go to that information to the eldest person in the community who would remember when the highest rainfall would have been and where the water level for that section of the river would have been. And then that's what we used as our reference for our high water level. And then we designed to be much more above that. That way, if ever it rains to that extent again, we have the clearance that we need for any debris to go underneath the bridge. Yes.
So with a cable that's 260 feet long, how do you get, do you have machinery, or how do you get enough tension to pull it and set it in place?
The question is, since the cable is so long, how do we get it across, and then how do we tension it? Getting the cable across, we use manpower. So that involves a huge day where we gather the community together to all pitch in, put on gloves, and grab the cable and help pull it across. Once the cable has been stretched across the river, we will loop it through the anchor and use a winch or come along to help tension the cable through a series of tensioning cycles. Any more questions? Last one. Thank you.